In this video, we're going to talk about a little bit of machine code. You can see the machine code on the left. And what this is going to do is going to execute this statement. We're going to take initial plus the rate times 60, and we're going to store that into a variable called position. On the right, we have a representation of our machine. We have our physical memory, right? Code, static, heap, and then here we have our stack, and that's where our variables are going to be stored. Here we have our two registers that we're going to be dealing with. And note that I've preloaded identifier numbers with each variable in the source code. Okay, so let's look at the first instruction. LDF is load float, and we're going to load the float from identifier 3 into register 2, right? So we're going to take identifier 3, that's the operand, and load it into the destination of register 2. And so once we've completed that operation, we're going to have identifier 3 in register 2. Next operation, MULF multiply float. We're going to take the contents of register 2, multiply it by 60, and place the result in register 2. So we're going to take ID 3, multiply it by 60, and put the result in R2, or register 2. Next operation, LDF, again, load float. We're going to take ID 2 and load it into register 1. So now here we have ID 2. Next operation, this one here, add F means add float. We're going to add the contents of R1 and R2 and place the result back in R1. So what happens is this value here doesn't change. R2 is just going to remain the same, but R1 is going to get replaced by ID2 plus ID3 times 60. Okay, so that's an actual value we have in R1. And then finally, we have STF, which is store float. We're going to take the contents of R1 and put them into memory at the location where ID1 is.